Although Midi has been around since the early 80s, it's far from obsolete. To make the most of it though, you need to understand some basic concepts. There's a lot more to Midi theory than what I'll be covering here, but it'll give you an understanding of how it works, so that you can more easily tackle any Midi problems that you may encounter in the future. You can think of Midi as a remote control for your keyboard. When you hook up a keyboard to a computer via Midi, you can record, edit, or play back your keyboard performance using a software sequencer. Compared to recording audio on a computer, Midi is extremely efficient. Even a very slow computer can breeze through a complicated song with lots of Midi tracks. That's because Midi is basically just text information, which makes Midi and audio completely different. Midi is not sound. It's a control language. For example, when you press a key on the keyboard sends out a Midi message called Note On. When you let the keyboard up, the keyboard sends out another message called Note Off. And these messages are exactly the same whether they're playing the sound of a piano, a Rhodes, or a drum sound, or anything else. In order to hear the Midi notes that you're playing on the keyboard, you need to send that Midi data to a synth or some type of sound module that makes the actual sound. Midi commands are carried on Midi cables, or over a USB cable. If you're using standard Midi cables, you'll need to connect the keyboard's Midi out jack to the computer's Midi in jack. And if you're using a keyboard as the sound module as well, you'll then need to connect the Midi out of the computer back to the Midi in of the keyboard, so that the Midi messages can travel back into your synth. Most of the sound modules that we use these days are software-based, thus we rarely use sounds from external hardware synths anymore, so I won't get into explaining how to connect external Midi equipment here. But because computers don't usually have built-in Midi jacks, the connections are made through the use of a Midi interface, which you can purchase separately, and are often supplied even with the prosumer or professional sound cards. If you're planning to use only computer-based software synthesizers, like one of these, any Midi keyboard or Midi controller will do the job. The difference between a Midi keyboard and a Midi controller keyboard is that a Midi controller keyboard, like this one here, has no built-in synth or sounds of its own. It's just a keyboard that transmits Midi controller information. Midi uses 16 channels or tracks for transmitting data. For a Midi track in your sequencer to play a sound, both the synthesizer and your controlling track have to be set to the same channel. Messages on all 16 channels can travel down a single Midi cable at the same time. One channel might play the bass line, for example, while another channel plays a piano sound. Midi's Note On and Note Off messages are used for starting and stopping notes. Each Note On and Note Off message includes a note number and quite a few other messages. Midi uses 128 note numbers, with middle C being note number 60. Although most software sequencers don't even display a note number anymore, but just show the actual note name, such as C3, which is middle C on a keyboard. In addition to a note number, each Note On message states a velocity value. If you strike the key harder, it creates a higher velocity, and if you strike the key more gently, the velocity is lower. Velocity values range between 0 to 127. Midi also has various types of controller data. Many keyboards have knobs, wheels, sliders, joysticks, or ribbon controllers. These can usually be assigned to one or more parameters, like filter cutoff frequency or vibrato amount, etc., and this data can be recorded by your sequencer. When the controller data plays back, you hear that knob or wheel movement just as you played it, even though the knob or the wheel isn't physically moving. Midi can use over 100 controller change messages, which can be used to change the sound in various ways. Some basic types of controller data are pitch bend, modulation, and aftertouch, which is generated by pushing down on a key while it's playing a note. Each control change message has a channel number, a controller number, and a value between 0 and 127. A few of the controller numbers have set meanings, presets. For example, controller change 64 controls the sustain pedal. Controller change number 1 controls the modulation wheel. Controller change 7 controls the master volume for that track. So for example, if you sent out a controller change 7 message that has a value of 0 on channel 3, the synthesizer that is receiving on channel 3 will respond by turning its volume down to 0 for that channel. The pitch bend message is unique in that it's bidirectional. 0 is the middle of its range, and you can bend down or up.
Here we have an example of the event view, or where you can see the details of the MIDI information which the program Sonar made by Cakewalk uses. On the left side, we have the bar that shows what track the MIDI information is on. Then the HMSF stands for the hours, minutes, seconds, and frames, which is in relation to how video editing uses timing. Then we have the MBT section, which stands for measures, beats, and ticks, which is how MIDI breaks down measures and timing. For example, we have 4 beats in a measure, with the first digit showing the measure, then the beat, as in 4/4 timing, we have 4 beats, 1, 2, 3, and 4. And then ticks, in this case, we are using 120 tick per beat resolution. And this means that our beat is broken down into 120 sections, or 120 ticks. Then we have the channel section, which shows what channel you were initially transmitting on and thus will play back on. Then the kind of MIDI information it is. In this case, it's a note, C3, G4, D4, and E3. Then you have wheel information, control information, and a variety of events that you can record, such as you see here. Here we have the data section, or value section, which shows here, in this case, that this is a note, shows what note we're playing. This is the wheel controller showing the amount of bending we're doing, 0, which is none, all the way to negative, and all the way to positive. Then we have controller change number 1, which is modulation. And then displayed in the value section, we have the value. In this case, C3 is being hit at a velocity of 1, which will barely sound. Then on to 80, 100, and 127 as an example. Here we have modulation all the way up at the full value, 127. And then this shows the duration of the note. In this case, this note is holding out for the duration of 1 beat, and so on.
And that takes us to the end of this basic overview of MIDI.